So let's use this limit process one last time, and this time we're going to consider another function, f of x equals x squared, and we're going to use it on the interval from 0 to 2, and we want to write a formula for the area under the curve using n rectangles. Now we could use either left-hand or right-hand limits. I've got this one set up so that we can do right-hand limits on this one. And we're going to set up our limit of summation, find that area, and then evaluate that limit. So we're going to check out, of course, the way that we work this through, recall, was that we're going to set up our width of each of one of these rectangles using the formula of b minus a divided by n, where a and b are the endpoints here of our interval. So in our case, we're going to use our delta x of 2 minus 0 over n, which is to say 2 over n. So each rectangle will have a width of 2 over n. And for each rectangle here, let's just go down to our ith rectangle here, just somewhere in the middle. We pick out a rectangle. We say, okay, what would be its area right here? Using the right-hand endpoint, we're going to take the y value to be f of, let's see, what do we say here? If we're starting at I equals 0, this is going to be I delta x. So for our purposes right here, f of I times delta x will be the same thing as saying 2 over n, which is delta x times I, quantity squared. And so that's going to be 4 over n squared I squared. And so our formula for the area right here, using n rectangles, would be the sum from I equals 1 to n of 2 over n, the width of each rectangle, times the height of each rectangle, which is 4 over n squared I squared. And so if we want to find the area itself using a limit, we would say that our area looks like it should be the limit as n tends to infinity, that is, as we increase the number of these rectangles here, of the sum from I equals 1 to n of 8 over n cubed times I squared. All right, so let's work that out right here. Of course, we're going to set up our formulas so we can get this. This is the same expression as the limit as n goes to infinity of 8 over n cubed times n, the sum from I equals 1 to n of I squared. Now remember that we have to find this summation here first before we can evaluate this limit. So we're going to set it up in order to do that. We'll recall that the summation from I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 over 6 as verified in class. And so when we find our area right here, we need a simplified expression for this. I'll note that n and n cubed cancel to give me a square right here, so a little bit of simplification should give me the following. I find I have 4/3 times 2 plus 3 over n plus 1 over n squared, and now as n tends towards infinity, I'm going to find that I have 4/3 times 2 plus 0 plus another 0 right here. And so my area under the curve here should be 8/3.